So good morning to all of you. So today we are going to solve the questions from alcohols, phenols and ethers. So good morning Vinay, good morning Chinu, good morning Chandan, Pavitra. Okay, so tell me, have you revised this chapter? Are you done? Have you done all the concepts from this chapter? Okay, so the questions I have taken are of the questions that you can expect in your KCET examination. Okay, so based on that, these all questions have been designed, so you can prepare, you can do all these questions. So what you have to basically do is you have to solve the questions with me. You have to post down your answers in the comment sections. Okay, and once that is done, once your answers are correct, you have to tell me your scores at the end of the session. Okay, so all of you are ready. Let's start, students. Good morning Pradeep, good morning Pooja, good morning Ria. Yes, all the very good morning to every one of you. Okay, yes, let's start now. New morning, new chapter and all the important questions. Let's crack it. Coming to the first question here, all of you can see on the screen, and now please answer it. Pradeep, we are going to solve 20 questions today. Okay, let me see who scores 20 out of 20. So students, please be honest with you, and I want how many of you will be scoring 20 out of 20. Hi Darshan, hi. Okay, so the questions I have taken. Yes, let's start with the first question now. Yes. Okay, 3-methyl 2-butanol on treatment with HCl gives predominantly. Okay, so whenever it is written predominantly, you should be thinking about the major product that has to be formed. Okay, whenever it is written predominantly, there is chances of forming more than one product, but we have to guess the major product. So you have this question, options is 2-chloro-2-methyl-butane. Okay, then 2-chloro-3-methyl-butane, 2,2-dimethyl-pentane and 3-chloro-2-butanol. Okay, so yes Darshan, let's see. So okay, now do this question. We have 3-methyl-butane 1-OL. Okay, 3-methyl-butane 1-OL with HCl. What do you think? What will be the correct answer here? Pratiksha has said answer option number A. Okay, those who are saying B, let me tell you, you are wrong here. The correct answer is option number A. So congratulations Pradeep, Pratiksha, you are done absolutely correct. Now see, here is something which happens through rearrangement. See what happens, what will happen? The protonation of OH takes place. This OH will abstract this H plus, right? Then what we will get a structure like this. Okay, we'll get a structure like this, that is O plus H2, right? Now this O plus H2 will move and we will get a carbocation here, right? We'll get a carbocation formed at this point of time. Now you see, this is a secondary carbocation. We have a hydrogen here. If we do a shift of hydrogen, if this hydrogen shifts here, carbocation will form here, and this carbocation will be more stable because it will be a tertiary carbocation, right? So here what happens, hydride shift takes place. Okay, rearrangement, we have studied rearrangement. Okay, hydride shift takes place, this hydrogen comes here. So what is the product now I am getting? We will get product positive charge on this carbon now, right? This hydrogen has moved here. Okay, this is called hydride shift. So whenever there is a possibility of getting more stable carbocation, rearrangement always takes place. Okay, so now this one comes here, so we got plus charge here. Now this Cl minus can attack here and we will get the product Cl is formed on this particular carbon. So now if I number it 1, 2, 3, 4, so I will get 2-chloro-2-methyl-butane. Option number A is the correct answer. Okay, so students, please tell me, did you understand this concept or not? Please put down in the comment section, because it is something little, not direct one, little indirect question, but yes, from now onwards we will remember what is the learning on this question. The learning is, whenever we have a possibility of more stable carbocation, okay, you should always think of rearrangement. Okay, so whenever a carbocation is formed, no, automatically your eyes should move towards the other two carbons beside that one. Is there any possibility of getting a stable carbocation or not? Okay, always keep that in mind, then you will not do this mistake. I hope everybody is clear with this. Now let us move to the next question. which of the following reagents can convert acetic acid into ethanol? Okay, conversion of acetic acid into ethanol. This is very simple question. Options are S plus HCl, H2 plus Pr, lithium aluminium hydrate, this is LiAlH4 plus ether, or Na plus alcohol. Okay, so yes, tell me. This is very simple one, easy question. Yes, Chandan has already given answer. Option number C is the correct answer here. Okay, now tell me whether this is an oxidation process or reduction process. Okay, whether it is oxidation or reduction. Please answer this one. Let me know how many of you know the basic thing. Whether it is oxidation reaction or this is a reduction reaction. Conversions of acids to alcohols. Oxidation or reduction. Is it oxidation or reduction? Yes, all of you are correct here. Chandan, all of you are correct. Yes. Very good. Yes. Yes. Very good. Very good, students. This is a reduction reaction. Okay. One table you have to remember here. See, alcohols on oxidation can give you aldehydes, can give you acids. Okay, so in this way, if I go, this is oxidation, mild oxidation, okay, and this one is also oxidation. Now if you come back, if you want to go from alcohols to acids directly, then it is what? Strong oxidation. Okay, now here to here is reduction and here to here is also reduction. Clear? Okay. Yes, Srinivas, this Masterstroke is enough for KCET. Please trust us and do this series, complete this series. This is definitely enough. Next question. An organic compound dissolved in dry benzene evolved hydrogen on treatment with sodium. It is what? Okay, so it is a ketone, it is an aldehyde, a tertiary amine, or an alcohol. So question is dry benzene, an organic compound is there. Okay, so it evolved on treatment with sodium and dry benzene is there, and you got hydrogen gas, okay, or hydrogen is produced. So what can be this compound A? Yes, D is correct. Yes, D is correct here. Okay, all of you are correct. Let's move to the next question. Oh, sorry. Yes, and compound X with molecular formula C3H8O can be oxidized to a compound Y with the molecular formula C3H6O2. X is most likely to be, okay, so you have one X, okay, which is C3H8O, and then it is getting oxidized to C3H6O2. Okay, so what is, okay, so you have to guess what is this X, whether it is a primary alcohol, it is a secondary alcohol, it is an aldehyde, or it is a ketone. Okay. Yes, no. 4A, Pooja is correct. Pooja is correct. Here, see students, this is one alcohol. Okay, we know alcohol. This is an acid. You can see there is 2 oxygens, right? 2 oxygen means the functional group has to be an acid functional group. So if there is, and we know that only primary alcohols on oxidation can give you acids, right? Secondary alcohols on oxidation will give you ketones only. This secondary alcohol cannot give you acids. Okay, primary alcohol on strong oxidation, just now I discussed, right? Primary alcohols on strong oxidation will give you acids, right? So that is why here correct answer is A, not B. Is it clear? Tell me, so many students have answered B, I don't know why. See students, very simple thing. If you have primary alcohol, you can oxidize to aldehydes also, you can oxidize to acids also. For oxidizing to aldehydes, you have to use mild oxidizing agent. For oxidation to acids, you have to use strong oxidizing agent. Now, by seeing the formula, we can easily say that two oxygens are there, so it has to be an carboxylic acid group. Right? Now we know secondary alcohols cannot be oxidized, primary alcohols can be oxidized, so answer has to be primary alcohols. Okay? Yes. Okay, so Sobha is asking why does aldehydes and aldehydes cannot be the answer. See here, Sobha, see, when you have this formula C3H8O, okay, just let me write down this one. Okay. See, Sobha, please see this question. Your question is very good. So Sobha has asked a very good question, why it cannot be an aldehyde. So you can see, if I have to write a 3-carbon aldehyde, then what has to be the molecular formula here? 1, 2, 3, 4, 5, 6. So I will have C3H6O. Okay, but if I write an alcohol, 1, 2, 3, so I have 1, 2, 3, 4, 5, 6, 7 and 8. The molecular formula is also to be satisfied, right? The molecular formula should also be satisfied. If you take aldehyde, the molecular formula is different. Here the molecular formula is different, right? So that is why it is not an aldehyde. Okay, Sobha, I hope you are clear, your doubt is clear. Okay. Now let us move to the next question. So all of you are clear now, primary alcohol. Okay, most of you answered secondary alcohol, which is very, very disappointing. I have told you many times, secondary alcohol on oxidation will give you ketones only. Okay, fine. Now let's move to the next one. Question number 5. Absolute ethanol cannot be obtained by simple fractionation of a solution of ethanol and water because, okay, so you cannot separate ethanol from water by simple fractional distillation. What is the reason behind that? Okay. Okay, so is it because their boiling points are very near? Ethanol remains dissolved in water. They form a constant boiling mixture. Ethanol molecules are solvated. What can be the reason for this question? Yes, students, very good, very good, very good. See, we have studied in the solutions chapter. Okay, what is the name of these type of mixtures which boil at a constant temperature? Tell me the name of, what is the name given to the mixtures which boil at a constant temperature? What is this mixture called as? Anyone can answer me this one. What is the name of the mixture given? Yes, Chandan is correct. Azeotropes. Yes, very good. We have studied in the solutions chapter, right? Moving to the next question. Phenol is what? A weaker base than NH3, an acid stronger than carbonic acid, an acid weaker than carbonic acid, or a neutral. Phenol is a neutral molecule, or it is a basic property, it has an acidic property, and it is a stronger acid than carbonic acid, or it is a weaker acid than carbonic acid. Yes, sixth question C, all of you are very correct. It is an weaker acid than carbonic acid. So please remember H2CO3. Okay, so if it is a weaker acid than carbonic acid, then what will happen? Phenol cannot react with carbonic acid. Okay, it is a weaker acid than carbonic acid. Yes, all of you are absolutely correct here. Next question. Phenol on sulfonation will give you, this is very easy question. Phenol on sulfonation will give you orthophenol sulfonic acid, paraphenol sulfonic acid, metaphenol sulfonic acid, or a mixture of ortho and para phenol sulfonic acid. Yes. Yes, students, Correct, all of you are correct. C, those who are telling, that is correct. 7th, D is the correct answer. Very good. Mixture of ortho and parasulfonic acid. We know what phenol is a electron donating group, right? Electron donating group means what? It is ortho and para directing. Okay, it is ortho and para directing. So sulfonation will take place at ortho position and at para position. Okay, yes, very direct and easy question. Let's move to the next question. Primary and secondary alcohols on action of reduced copper will give you. Okay, means if they are undergoing reduction in presence of copper, what will be the product? Aldehydes and ketones respectively, ketones and aldehydes respectively, only aldehydes or only ketones? Very easy question. Yes, 8th A is correct, aldehydes and ketones respectively. Okay, so primary will give you aldehydes, secondary will give you ketones, tertiary will give you alkenes. Please remember that one, tertiary will give you alkenes. Okay, very good all of you. Next question number 9. Phenol does not react with, just now I told you, just now we discussed this one. Phenol does not react with Na2CO3, NaOH, NaHCO3 or KOH. Yes, NaHCO3 or Na2CO3, NaOH and KOH. Just now I discussed. Yes, Vishma, it is enough. Yes, just now we discussed, right? With carbonic acid it will not react. So here there is carbonic acid, it will not react with that one. So you have option number C is the correct answer here. Yes. Next, question number 10. Lucas reagent is used to distinguish among primary, secondary and tertiary what? Alkyl halides, aliphatic amines, alcohols or aromatic amines. So what is this one? Yes, those who are saying C, it is absolutely correct. Very good, students. Okay, next. Yes, alcohols is the correct answer. Okay, here some numbering is wrong. Sorry, this is B and this is C. Okay, alcohols is the correct answer. So you should remember primary alcohols, okay, with Lucas reagent, that is ZnHCl, right? With Lucas reagent, no reaction. Okay. Secondary alcohols, reaction within or after 5 minutes. Tertiary alcohols will react immediately. Okay, so whenever there is reaction happens, you will find turbidity. Okay, turbidity is produced. Okay, yes. Next, question number 11. Increasing order of acidic strength among para-methoxyphenol, para-methylphenol and para-nitrophenol. Very important question. Very important question. You have para-methoxyphenol. Okay, so that is OH and OCH3. Para-methoxyphenol. Then you have para-methylphenol. You have para-methylphenol. And then you have para-nitrophenol. Yes. Yes, 11 is the correct answer. See, here we have electron withdrawing group. So what is the concept here? Electron withdrawing group will increase the acidity, electron donating group will decrease the acidity, right? So NO2 is withdrawing group, OCH3 and CH3 both are electron donating group, right? So definitely this one will have more acidic nature. So para-nitrophenol will be the highest. So here it is highest, here it is highest, here para-methylphenol is given, so we can eliminate. Methoxyphenol is given, we can eliminate. Okay, now coming to the next option. This one donates by resonance. Okay, and this one donates by inductive effect. Okay, and you know resonance effect or resonance effect is more dominant than inductive effect. Okay, so that means this will donate more. If it donates more, it will decrease the acidity to the least, so that is why this one will be least. So here we have para-methoxyphenol. Correct answer is option number B here. Okay, yes, I hope this is clear. This type of acidity order based questions are very, very important and can be expected, so please practice this one. Okay, next question number 12. Complete the following reaction. Phenol is given, zinc dust, CH3Cl anhydrous AlCl3, then alkaline KMnO4. Very easy question. Yes, tell me this one, how much what will be the product formed here? Is it benzene, is it toluene, is it benzaldehyde, or is it benzoic acid? Yes, Chandan is super fast today. So we have phenol. Okay, if you treat it with zinc dust, okay, then X will be what? X will be benzene. Okay, then if you have CH3Cl AlCl3, this is your Friedel-Crafts reaction, right? So in Friedel-Crafts reaction you will get here CH3. Then I will have here alkaline KMnO4. So alkaline KMnO4 will change this one to what? Acidic group. Okay, so COOH, that is benzoic acid, option number D. Okay, yes, absolutely correct, students, very good. Next we'll go to next question. You have this question, if it is not visible I'll draw it again. You have this one. Okay, I am drawing it again. There may be some blur picture here. You have CO2. Okay, then you get X. Okay, then you get HCl. If you treat it with HCl, you are getting this one, OH and COOH. The question here is, what is this X? Okay, what is the X? This is also very important question. Yes, X is ONaCOOH, COONA, OCOONA, OHCOONA. So the question is not asking you the final product, it is asking you the mid product. No, students, this is which reaction, can anyone tell? This is which reaction? This is Cole's reaction. Okay, this is Cole's reaction. So what happens here? First, no, when this one is there, O minus is there, see. Okay, this comes like this comes like this. Okay, so the here what happens, we get like a product formed here is C double bond ONA, okay, and OH. Okay, this is the product formed here. Okay, here we get this one attacks on this carbon and this Na plus takes, and this H and Na get exchanged. Okay, so after that, once you give HCl, this gets converted to COOH. The correct answer here is option number D. Okay, yes, very good. Those who are saying Cole's reaction, it is correct, but intermediate, see how, if this question, if this would have been asked, all of you would be able to answer, but when X is asked, it is little confusing, right? We get confused between A and D. Okay, so mostly the correct answer, means the correct answer here is option number D. So first what happens, this reaction comes, this attacks on CO2, okay, then it reverses. After that, there's a proton exchange here, H from here goes here, Na comes here, and we get this one. Okay, please all of you will remember this answer now. Okay, next question number 14. The reaction products of the following. So you have C6H5, okay, this is your reaction of ethers, right? OCH3 with HI. What will be the product? This is very easy. Whenever there is this group, you should be knowing what should be the product. This is very easy question. Chandan, I will answer your question. Okay, I will answer your question at the end. Okay, now let us complete this discussion. Yes, Chandan, I'll discuss this question at the end. Okay. Yes, A is the correct answer. This bond will break here. Okay, so you have C here, OH will form, and here CH3I will form. Okay, yes, all of you are correct. This one should be very easy. Now let me discuss Chandan's doubt here. He has asked a very good question. So how to identify which one will attack here? Now see, you had this one, right? ONA was there and CO2 was there. Now if you see, okay, if you see, this one is actually in the form of O minus. Okay, so now this O minus, it is an electron donating group, so attack will take place in the ortho and para position. But when we see options, the substituents are in the ortho position, right? So basically we can guess that, okay, in this question there is ortho attack, so this one will come here. Okay, this bond will come here. So what I will get, we will get a structure like this, where this one is there and we have this one, okay, and you have one H here. Now this minus will attack on the carbon dioxide group. This one will attack here, okay. Now this one will attack here and this bond will come here. So what I will get, you will get a structure like this. You will get a structure like this H, okay. Then you have C double bond O and O minus, okay. Now here we have double bond O. Now the aromaticity of the ring is disturbed, so what will happen, this oxygen lone pair is there, right? So what, or this oxygen is also there, so what will happen, this oxygen, this bond shifts here, this bond shifts here, and this lone pair abstracts this hydrogen. So what I will get here, I will get OH double bond COO minus. Now you remember in the starting this Na plus was present, so this Na plus will come here. Okay, so that is how the mechanism is formed. I hope this is clear, Chandan. Okay, fine. Now let us move to the next question. 1 second. Yes, question number 15. Yes, in the following compound, the order of acidity. Again, a very similar question based on the acidity. You have phenol, you have para-methyl phenol, you have meta-nitrophenol and para-nitrophenol. Acidic order, all of you can guess, I think. Yes, students, can you answer this question quickly? (15) is D. Yes, Pradeep is correct here. So this is again electron withdrawing group, right? Here electron withdrawing group, here also electron withdrawing group. So definitely they will be fast. Now here you see electron withdrawing group at meta position will have minus I effect. Electron withdrawing group at para position will have minus R effect. So definitely this fourth one will be a maximum. So we can have only one option where fourth is maximum. So definitely option number D is the correct answer. Now here if you see 2 and 1, here this is an electron donating group and I can consider this as a neutral molecule. Means no groups are attached. So electron donating group will decrease the acidity, neutral there will be no effect. So there will be after 1. Okay. Yes, all of you are correct here, all of you are correct. Now let's go to the next question, that is question number 16. Okay, let me, yes. Paracresol reacts with chloroform in alkaline medium to give compound A, which adds hydrogen cyanide to form compound B. The latter on acidic hydrolysis gives a chiral carboxylic acid. The acid is, yes, you are getting a chiral carboxylic acid. I am standing aside so that all of you can see the question. Please read the question correctly. Yes, anyone can answer this one. No, Pooja is wrong. Okay, fine. I am explaining this question. I am explaining, many of you have not answered yet. Okay, see, what is paracresol? Paracresol is OH and CH3, right? This is paracresol. Now when you treat it with chloroform in alkaline medium, CHCl3 in alkaline medium, this, can you say which reaction this one? Reimer-Tiemann reaction, right? So what will happen in Reimer-Tiemann reaction? OH is produced, and sorry, beside OH CHO has come, okay? So here what happens? We get CHO. Now compound, to give compound A, so this is your compound A, okay? Next, which adds hydrogen cyanide to form compound B? So you have to add HCN, okay? If you add HCN, what will happen? Nucleophilic addition reaction takes place here. See, Cn minus is there, this one will attack here, this one will attack here. We know nucleophilic addition reaction. So we have here OH and CH3, and you have COH, Cn and H, okay? That is what is present now, this one. Now can you see this carbon is a chiral carbon, right? Now when you do hydrolysis, okay, on acidic hydrolysis gives a carboxylic acid. So if I do hydrolysis, this one will give me, yes, so this one will give me COOH, okay? So what is there? You have one carbon OH, okay? So beside OH there is CHOH, COOH, that is your option number B. Now you can easily eliminate option number C and option number D, because this is not a chiral carbon, right? There is no chiral carbon here. So we can easily eliminate these two options. Now after these two, we know that this comes whenever there is Reimer-Tiemann reaction, at ortho position aldehyde group is formed, okay? Okay, so students, please tell me, did you get this question? Please answer. Did you, all of you, understood this question? Please tell me in the comment section. Yes, students, please tell me. I found most of you were stuck in this question. Is it clear? Any doubt here? Tell me, I will explain again. Any doubt to anyone? Please tell me, I will explain again, or else we'll move towards the next question. Those who have understood, please put a thumbs up or let me know that all of you have understood, or else I will explain it once again. Anyone having doubt, please don't feel any shy. You can ask me, I can explain it once again, or else we'll move to the next question. Okay. Fine. So this is very simple. You should be able to identify this reagent first of all, okay? Now once this is come, we have know that CHO group will be attached here. This is Reimer-Tiemann reaction. Now after that, whenever HCl is added, right, that is your OH and Cn is added. So you will get cyanohydrine. After hydrolysis of cyanohydrine, you will get. By reading the question, you should be able to eliminate option number C and D, because it is given a chiral carboxylic acid, but there is no chirality in these two compounds. Now after these two, you should be confused with option number A and B. Now we know that para group is already blocked and OH is a okay, in this there is no phenol also. Sorry, I didn't see this one. You can see here there is no phenol. You see paracresol is there. Phenol group should be there, right? But there is no phenol here. So definitely option has to be option number B. Okay. Okay, some students are having doubt. Chandan, this is a question from alcohols and aldehydes chapter. Okay. Clear? Okay, once again I will explain. Okay, some students might have doubt, so please understand this question properly. You have para or cresol, okay, that means OH and CH3, okay. Next, you have been treating with chloroform, okay, and alkaline medium. So this is your Reimer-Tiemann reaction. If you haven't studied, it is there in your aldehydes chapter, okay. This is Reimer-Tiemann reaction. Then you are treating it with HCN. So this will take nucleophilic addition reaction. This will attack here. This bond will go here. O minus will attack on H plus. Okay. So I will get here OH, COH, CN, H and CH3. Now after this, what will happen? Hydrolysis. So hydrolysis will convert Cn to COOH group. Okay. So you will get like this. You have OH. Okay, one second. This is OH. Okay. OH. Then here you have COH, COOH and H and CH3. Okay, I hope this is clear to everyone. Okay, all of you are clear, students? Now, is it any doubt in any step? Please tell me. This first step, if you can identify, then the rest part is easy. The first step, you should be able to identify it. Okay. Okay, please let me know if this question is clear to all. Let me go to the next question then. Question number 17. Okay. Yes. Can we guess these questions? You have phenol, you have CH3Cl3 and NaOH, so the same reaction that we discussed right now. Okay, so this is your Reimer-Tiemann reaction. Reimer-Tiemann reaction. So what is the electrophile involved in this Reimer-Tiemann reaction? Yes, it is a dichlorocarbene CCl2. Option number B is the correct answer. Okay, option number B is the correct answer here. No, Pratiksha, it is not a carbocation. In this reaction, it is a radical mechanism or a carbene mechanism. We get dichlorocarbene as the dichlorocarbene is the thing that behaves as an electrophile. Okay, these two mixture produces dichlorocarbene. Okay. Next question. Question number 18. The structure of the compound that gives a tribromo derivative on treatment with bromine water is. This is also a tricky question. Yes. The structure of the compound that gives a tribromo derivative on treatment with bromine water. So we know that when we treat phenol with bromine water, we get tribromo derivative. So which of the following phenols, when you treat it with bromine water, you can get tribromo derivative? Okay. Which of the following compounds on treatment with this one, that is bromine water, will give you tribromo derivative? Uttam has answered, then Madan has answered. Yes, A is the correct answer. A is the correct answer. See, why? This is not a phenol. Okay, so here no reaction will take place. Here reaction can take place, but one of the ortho group is blocked. So this cannot be the answer. This reaction can also take place, but here this para position is blocked. This can also be not the answer. Here if you see phenol group is there, the ortho positions are free, even the para positions are also free. So this can give you a tribromo derivative. So option number A is the correct answer. Yes, all of you are correct here. All of you are correct here. Now let's move to the two easy questions. Last two questions, very easy one I have given. Which reagent will convert propionic acid to propane 1-OL? The similar question we have discussed in the starting as well. Propionic acid to propane 1-OL. (19B). Yes, Pradeep is correct. Lithium aluminium hydride will give you acids to alcohols, right? Direct question, reduction mechanism, very strong reducing agents, alcohols are produced. Okay, last question, students. The reaction of ethanol with H2SO4 does not give. Okay, does not give. Be very careful. Which one is not produced here? Yes, can we answer this question? The reaction of ethanol, very this is also good question, or I can say tricky question. CH3 does not give. Be very sure what is asked in the question. Does not give. Yes, Madan is very correct here, very correct. I was expecting most of you will do wrong, but yes, 20C is the correct answer. Let us understand this one. See, if you have CH3, CH2OH, if you heat with concentrated H2SO4, okay, at 443 Kelvin, what will happen? We will get ethene, okay, dehydration reaction. If you heat ethanol with concentrated H2SO4, okay, at 413 Kelvin, then you will get ether, right? So we can get this one, we can get this one. Now how we will get this one? If this one CH3 CH2OH reacts with H2SO4, okay, so this is what, this one is donating one H plus, right? So this is like this, see, H plus and HSO4 minus, right? So this can react with this one, so I will get here CH3 CH2OHSO4, okay. So you can get this as also, but this one will also be produced, but this one we cannot get at any condition. So option number C is the correct answer, okay. Yes, okay, that's all students, I hope. Yes, now please put down your comment section in your scores. I want all of you, all the 20, 25, 30 students, whoever were watching, please tell me your scores quickly. Let me see who has got the highest marks today. Yes, and tell me students, are you finding this series helpful? Please trust us, okay, if you do these type of questions, okay, it's not like if you do only these questions you will definitely qualify, but yes, you will have a practice and we will do more questions as well, okay. So it's not like we are complete, we will do only this 20 questions, no, we will bring up with many more questions, test series, everything will come, but you should be with consistency. You should be, today you did 20 questions which are of KCET level, that is absolutely perfect, okay. So yes, please tell me and any other concerns. Somebody has commented, how is your preparation going on? Please let me know, okay. Any problem, challenges you are facing, how is your board exam preparation going on, any other help you want, please trust us, I will be there for you for any help in the exam that is needed, okay. For your preparation, whatever is needed you can tell us, we will be doing everything that is required, okay. So artist, Mr. Artist, my next live will be on Monday, okay, Monday 11 AM. 2 chapters we will be doing: aldehydes, ketones and carboxylic acid and amines, okay. So aldehydes, ketones, carboxylic acid and amines you should be revising between Saturday and Sunday. So what is your task? I'll give you a homework here, okay. So what is the homework for everyone? Homework: revise aldehydes, ketones, carboxylic acid and amines chapter, okay. This video KCET one shot you will get today, okay, and this one you will get on Sunday. So today you revise this chapter, today and tomorrow. Amines is a small chapter, you can do it in one day. Sunday you should be studying, okay, okay. Saksham and Harshada, please do not discuss anything that is not related to academics in this platform, okay. If you Pradeep, today you will be having class at 3 PM. That will be, you will be getting my KCET one shot on aldehydes, ketones and carboxylic acid. Tomorrow it will be maths and physics. Sunday you will again get amines one shot from my side, okay. Mohammed, you can see questions, the more you solve you will get better and better. It is not like if I just solve this 20 questions that is enough. It's not like that. You have to solve always some questions. The more you solve questions you will be more perfect in the concept, okay. The questions that you got wrong today, you have to solve similar questions like that. Which concept was that, from where you got wrong questions, you have to solve similar questions, okay. Uttam, KCET test series will start, okay, in this week only it will start, but it's a surprise for all of you, so I won't be revealing the dates and all, but very soon, okay. Just you have to just wait for some days, it will be coming, okay. Thank you Pradeep. Mohammed, these are not PYQs. These we are doing questions, expected questions other than PYQs only. So you can practice these questions. None of these questions are PYQs, but these are similar questions. Okay. Okay. Fine students, that's all, and I hope you don't have any other problem. All of your preparations are going superb and you are putting 100% efforts in this last 1 month. PU2 also we are having check review series. You watch our Brahmastra series. For chemistry, I will definitely recommend you, please go and watch the Brahmastra series for MCQs. Try solving the questions with us in the check review series. You will be able to get out in chemistry if you really work hard with us. Whatever things that is difficult, we are coming up, we are bringing up to you. So please. Okay, fine students, that's all, and I will take a leave here. So please start studying like 10 to 12 hours, 8 to 10 hours, I can say. At least this much efforts you have to put. Make a proper study timetable and study. Okay, whichever subjects are weaker, give more time. So try to get 290 plus in PCM. Okay, this is very, very important. This will help you to get a very good rank in your KCET examination, so that you do not have to work very hard for KCET. So make sure that in your boards you like really kill the board exams. Okay. Okay, bye students, bye. Yes, Mohammed, you can watch. You have to watch a 60 out of 60 KCET series to complete the whole KCET syllabus. Okay, okay. Bye students. That's all, and see you soon on Monday with these two chapters. All of you should come prepared. Okay. Chalo, bye bye. Take care, and now go back and start studying. Take a small break and start your preparation again. Okay. I'll see you all on Monday.